Hello, welcome to our channel for probability and statistics. In this video, we will talk about hypothesis testing on the slope coefficient in linear regression. So we know in linear regression or in simple linear regression, it's just a model to depict the relationship between y and x, where x is the independent variable and y is the observations or dependent variable. So this line is also called the fitted line or the linear regression line, with the y hat equals b0 plus b1 times x. And this line is used to as closely as possible to model the real line. This is the real line, but we never know. So in regression, we using the model to estimate the parameter based on the sum of squared errors of this term to be minimum. Then we can get these two parameters. And this error is called error term. EI is the difference between observations and the fitted point on this line. And this one is epsilon, is the error term in the real linear relationship. So this line is the real line given x value and the mean of the y value given x value. Because each observation is also randomly observed, randomly modeled, so based on this real line also we'll add an epsilon or random term in regression modeling. And these two parameter estimated, also called point estimate for intercept b0 and slope b1, come from the observed data x and y, where x are deterministic variable and y is a random variable. And here we use some notations. For sxx actually is the second moment of x with respect to its mean value, and syy is corresponding for the y, and sxy is the cross product of x against x bar, x mean value, and y against y mean value. So we have this notation, we can get the point estimate b1 actually is sxy divided by sxx. Also, one important term in linear regression is called SSE, which actually is the sum of squared errors. So if you look back, the sum of squared errors of this term. So this SSE actually is syy minus b1, the estimated slope, times sxy. And s square also is the SSE divided by n minus 2, which is the degrees of freedom. So this one, s square, is an estimate of the epsilon's variance, sigma square. And this term equals syy minus b1 sxy divided by n minus 2. Here we use minus 2 because two parameters b0, b1 estimated, so the loss of 2 degrees of freedom in the estimation of this regression line. So next we can do hypothesis testing on the slope. So the slope of b1 parameter is the most important, which we will focus on in the linear regression. And b1 comes from x and y, and the y value follows a normal distribution. So b1 also follows a normal distribution. And the one term n minus 2 s squared divided by sigma squared, so here is square, follows a chi-squared variable with n minus 2 degrees of freedom. So this term t, which is a division of two parts. So you can see the enumerate actually is a standardized normal distributed random variable, because b1 minus its mean and divided by its standard error. So this item follows a standard normal distribution, and s divided by sigma follows the square root of a chi-squared distribution random variable divided by its degrees of freedom. So, based on the definition of t distribution, this item is a division of a standard normal distributed random variable by the square root of a chi-squared random variable divided by its degrees of freedom. So this term follows t distribution with n minus 2 degrees of freedom. So this t actually is b1. This is the estimated point for the slope minus its mean value, the real value of a slope, divided by the s divided by square root of s-axis. So this term follows t distribution with n minus 2 degrees of freedom. Then we can test the null hypothesis that beta 1 equals beta 1 0 against a suitable alternative hypothesis. Can use the t distribution to get the critical region. So next we look at an example. So with the following table data for x and y, we can get the point estimate of b1 in a linear regression is 0.90. So the question is test the hypothesis that b1 equals 1.0 against the alternative hypothesis that b1 less than 1.0. So this problem actually is a one-sided t-test. So we form the hypothesis h0 is b1 equals 1.0 and h1 or alternative hypothesis is b1 less than 1.0. So we calculate the t value, then fill in the value of estimate the point b1, and 1.0 is the value we against in the test, and divided by s and divided by the square root of sigma. Then this value is minus 1.92, and this value follows 31 degrees of freedom of a t distribution. And in a one-sided test, we can get the p-value which equals the left side of this value and a t distribution density curve. So this area is about 0.03. So this p-value is quite small, or say less than 0.05. So we can say the test is significant in this hypothesis testing on the slope. Or we can say we have relatively strong evidence suggesting that the beta value less than 1.0. Or say the linear regression's slope less than 1.0 from given observed data in our problem. Thanks for watching.